Okay, welcome to the next video in the systems programming video series. We just finished assignment 5, and so I think I'm going to move on to this JAM 2. JAM 2 seems to be kind of like a practice, or I don't know, maybe like a quiz or a group project or something like that. In any case, it's got a few questions, somewhat conceptual, but also involving some programming. So let's get into it. Let's do at least problem 1. When Cedric runs his program with Valgrind, he gets the following error: invalid read of size 4. So it is coming from main. I guess there are line numbers here, but we're not going to be able to make any use of the line numbers because the program is down here. But let's maybe just jump into the main, see if we can't detect a problem which might have come from some kind of a read with some kind of a size 4. So we start off an integer n, can't be any problem with that. We malloc n objects of size int in something that is declared as a pointer to int values. So that seems fine so far, as long as we only keep 10 values. We do a for loop, upper bounded by n, which is 10, so that seems fine. Assigning to the coordinates of values using just I, so no problem so far. We compute this rand mod 10 minus 5. Now, I don't know if that would get computed as mod 10 and then that value minus 5. Next, we free the values. That's probably the issue because more code comes below, right? If we use values after we have freed values, then the behavior becomes unpredictable. So what does Valgrind error mean? So invalid read, I think reading makes sense that that would be the problem because we are trying to access index I of this array. So that's a read, and the size being equal to 4, I think makes sense because ints are stored in 4 bytes, right? Inside a block of size 40 freed, right? And that's 40 bytes because that was 4 times 10, right? 4 bytes per int with 10 ints. So I think that makes sense. Is there anything more we ought to say? Block was out free values command and move it after this for loop. Okay, so there is question 1. That didn't take too long, so let's try to do question 2. Consider the program linklist.c, which is checked into your JAM directory. This is JAM2, J2 in the cloned assignments. And so we declare a struct and a function to make the struct, and then a main function to make instances of the struct and do stuff with them. Okay, so what does it ask us to do? In the space above, draw the function stack for the following program at the end of main. So once main is completely finished, you do not need to include intermediate values in your diagram, just the state of the stack, and do not use ctutor because I don't want to take the time and effort to get out drawing equipment. But so let's just say that here in main, this would be level 0 of the stack, initially. We make this instance of cake making a call to make cake. At the time when this is called, then we add onto the stack, right? And this call to the function becomes level 0. Main now becomes level 1. And inside of here, we make a new cake, we copy over the passed in name, which would be red velvet. We should probably notice that names need to have 15 characters at most. So what is this? It's got to be less than 15, and this is less than 15. So I don't think we're running up against size limitations. And you pass in flavor and float cost. So that's a float, which comes over to here, which all seems fine. We set next cake equal to null. And so we copy over at most 16 characters. Now, I think because flavor itself is a string, then it implicitly has a string literal, so the copy will in fact grab that null character at the end of this string literal. And so I think that's fine. So basically all this runs, it returns the new cake, which is an instance of cake, and we assign that to cake 1. Very similar thing happens with cake2. And by the time the function has terminated, then this used to be level 0 of the execution stack when we were in the middle of running this function. But as soon as the function is done and we exit the function call, now that is pulled off and main returns to being level 0 of the execution stack. So now that we're down here, we're still in level 0 of the execution stack. We pop back up in the call to this function, but then we come back down when the function has terminated. These 3 commands have all been executed. Then there's some variable called cake1, another called cake2, cake3, and each one basically stores at the address of that variable these structs, the memory involved in these cake structs with the given data. And each one, by the way, is pointing to null, right? Because when you call make cake, you always make the next pointer null. So all 3 of these are pointing to null. But in the next line, we say that cake1 has a next pointer pointing to the address of cake2, which I think makes sense. So the cake1 is pointing to cake2, cake2 is pointing to cake3, cake3 continues to point to none. And at the end of main, that's basically what is going to be in your execution stack. So the only thing in the stack is level 0, which is for the main call. And it's got 3 variables, cake1, cake2, cake3. Cake1's next pointer points to cake2. Cake2's next pointer points to cake3. Cake3's next pointer points to none or null. So that's the stack diagram. Does this have memory leaks? Why or why not? Well, memory leaks are what you get when you fail to free up memory that you allocated. So certainly since there's a star here, we have pointers. Would that be a memory leak if we did not free the memory for the pointers? Well, we didn't alloc, right? So I would say no. These are just pointers. Since we did not malloc anything at any point, then I don't think we need to free anything. And so, we could null the pointers, but that's not like a memory leak issue. So I would say no, it has no memory. Okay, in the linked list file, add a 4th cake at the end of the list. Should be pretty simple. Yes. So we come over here, we say cake 4 equals make cake 4th and 1. And I think the intention is that we would say cake3.next points to cake 4. So is there anything else we need to do here? I think that's all it wanted. In the file, linked list, implement a function cheapest cake that prints each cake followed by the cheapest one. Okay, so just print them all, and then at the end, print which one you found was cheapest. Below is an example. Okay, so this one, this one, this one, this one, and then the cheapest is this one. Okay, your function should take the first cake as an argument. Sure. So I think there the challenge is to draw this function, right? Implement a function cheapest cake. Is the prototype already given somewhere? No, we are meant to write the whole function. Function and prints each cake followed by the cheapest one below as an example, but I don't think it returns anything. Yeah, okay. But its argument is a struct cake. Is it a pointer? First cake as an argument. So I don't know that it's a pointer, so I'll just call it C. And so this is my first cake, and then I want to make a temp cake that will cycle through all the available cakes. So let's say struct cake temp. Oh, what am I thinking? No, not min.next. Let's say C. Yeah, so C dot next, right? So C will be the thing that'll move along, but min will be the thing that is always smaller as much as we can make. We will make that happen. So if C dot next is less than min dot next, then we replace min with C. In any case, we are always going to say that C is updated with C dot next, so long as there is a next. Once we, oh, right, and I guess this needs to be not the pointer, but the object that is right there. So, okay. Now, right at the very end, we'll just do one final check and say if C dot next is, or sorry, if C, oh, what am I thinking? Because we can't talk about that. But so what I need to do is I actually, yeah, so C dot next, no arrow, cost is less than min dot cost, right? That's what we want. And then we want to say if C next, or no, if C cost, right? So at the very final check, wait. Yeah, that makes sense. Okay, I think that's good. And then if C dot cost is less than min dot cost, then we set min equal to C. And in any case, we will, oh, right. And along the way, we ought to print every cake. So I guess printf, and I'm going to be pretty lazy and just say name cost percent 0.2f, and that's going to come from C dot, what was it, flavor maybe? Yeah, flavor, and C dot cost. And at the end, we'll say print s, same thing, percent s, cost percent 0.2f, and we'll say cheapest, line breaks in these, and maybe I'll just say percent cost percent 0.2f, and this is all going to come from min dot flavor min. Okay, that I think should work. So let's come down to here, go into the jam. So that would be J2. And let's make, oh, there's supposed to be, oh, okay, so I can't make yet. All right, sure. So let's just say GCC, what was this read, no, linked list dot C and then dot slash linked list. It didn't print anything. Oh, right, because I just wrote the function, but I never call it, so. Oh, and main should return 0. Wonder why it didn't. So we would simply say cheapest cake. And if I gave it cake 1, then that should work, I think. Cheapest cake, $1 or whatever, and that is the correct cheapest cake. Great. Okay, I think, yeah, that ends question 2. This is already longer than I had intended to go, so we'll end it here.